Thank you for this opportunity to speak to you guys, and thanks for making the time. So this is quite a topic close to our hearts. Myself and Simon, who work for eSynergy, right? Data mesh has been quite a prevalent thing in the market over the last sort of few years. And we want to take this opportunity, like we take every other opportunity, to speak to people and fellow practitioners in the industry, to sort of share our experience about the data mesh. Simon, do you want to introduce yourself?
Yeah, I'm Simon Massey, Principal Consultant eSynergy. So yeah, I've been working on data meshes on my third implementation, second financial services client. And yeah, it was quite interesting that at the time when we started out on this journey, we happened to be engaged in organizations working with ThoughtWorks, and I was talking about the problems and got a sort of sneak preview of their thinking. And so we're sort of a little bit underway with experimentation, some of the themes when we had sort of got the paper landed for actually what the data mesh was, and that became sort of like, oh, now we understand what it is we're trying to do, and we can pivot towards implementing the practice in the data mesh when we already had a team up and running attempting to solve many of the problems of the data mesh from a sort of prior conversation with ThoughtWorks. So that's me. So I'm a technologist. When I get some time, I write some code when I'm on meetings. That's me, Simon.
Brilliant. Thank you. In terms of, what we want to talk about in terms of today's agenda, right? We want to talk about the principles of the mesh, and the impact on the ways of working. Also, we want to talk about how this can deliver business value at scale, and how we have learned of implementing this in large-scale enterprises.
So we were talking about long lead times, reporting and analytical use cases. As we know, sort of data warehouse, data marts, analytical data, on-prem, large financial service organizations, different clusters, very long lead times, spinning up new infrastructure, getting our analytical use cases live, getting our data together, getting our data products together, governing what's a data product, and doing all that was very, very hard. So we also find that in particular domains we're working in financial services, which is we're doing sort of bank-to-bank related activities. We find that the OLTP platforms can't cope with any of the analytical work cases, any of the machine learning work cases. And over time, there's a very bad pattern that's occurred of taking data out of the core platform, putting it into a data warehouse, struggling to do the analytical workloads, spinning up additional data marts. And we get a problem where we don't understand the lineage of the data. We get point-to-point integrations. Any project comes along and says, I want to do something analytical data, they can't go and put that new innovation on the same data marts. They've got to spin up the same infrastructure. They realize that they've got new fields they want out of the core platform. Now they have to deal with the core accounting platform teams, the ETL teams, the data warehouse teams. They have to spin up a data mart. Then to get it onto the API teams, they have to do some new work. So what we were seeing was in a large global financial service organization, the client was able to see sort of legacy reports off the accounting system mainframes. There was a new digital strategy, and they wanted machine learning and analytics and self-service reporting and all these kind of insights off to their end. But just to get one field to additional field that they kind of know is a regular reporting field, they want to sort of see it at the other side of their pipeline, they would have to do a sort of a change on the backlog to the talk to the core platform team, the ETL team, the data warehousing team, the data mart team, the API teams. And so if people were really driving forward that change, it would happen, but organically it would take a very, very long lead time, typically more than 9 months. If it's not a priority, it's never going to happen. So we also had scale issues. We sort of alluded to, if you want to innovate with data, do some new analytics and insights, we want to achieve something dramatic. How can we predict what the usage is going to be, the load? And, you sort of go into this planning exercise and trying to simulate to understand how to size your data infrastructure and how much you have to buy dev, UAT, prod, scale it for growth. And that sort of barrier is a huge barrier for entry. Basically, you only have to do the low-hanging fruit that you know will succeed. And often it's very hard to succeed. You never basically come back and say, hey, I have this great idea. Let's innovate a bit. Let's beat a test. Let's try something. See if the data quality is good. Spend, a little bit of time, a couple of months. And if it goes very well, feel it out, we'll roll it out, we'll do more with it. If it's not working out this year because our master data management's not quite there, we'll just shelve it and come back to it later. And basically, that would never happen. You would never be innovating. You know you're innovating when you try things and they sort of didn't really work. You shelve them, come back to them later. We haven't lost a huge amount of time. So to get to an organization where we want to say we have analytical data products that are well governed, we have cloud-based infrastructure, teams can come on, we can spin them up very quickly, they can do pay as you go, they can try and explore the data, they can build a quick innovation, they can get it on a dashboard, they can prove the value and then roll it out. That was the dream that people really looked for. Sort of touched on a little bit that we have huge amounts of handoffs on there that, you know, in order to deliver the value across the enterprise from backs all the way through middle, front office, everything down to, you know, corporate functions, data governance, etc. Huge number of handoffs. So how can we build a scalable data platform that had all the guardrails built in? We're mixed discipline teams who understood the core platforms and the ETL and the cloud engineering aspects, but they didn't have to understand everything. We create automation and guardrails that are repeatable. So it's very easy for a team who understands the core platform data to understand how to get data onto the cloud. That effectively we had it so that they can figure it out in 2 weeks. In 2 weeks, we can take them through the setup, prototyping, landing data into cloud, optimizing Dubai temporality. And at the end of 2 weeks, say, okay, now they're self-service, they can go off and add as many features as they want and start building the data products. Obviously, the idea of autonomy is coming here, that if we have just pure configuration on cloud and we have pay as you go, well, it can be self-service, it can be automated. All we need to do is just agree to set you up, make sure the right governance is placed to onboard you on the mesh, and then we can automatically provision all the cloud-based resources you need, the automation pipelines, the roles, etc., and grants. And then we're giving them basically the ability for them to configure what they want, how many ingestion pipelines, what the data products were, what the documentation is, and we were sort of doing that as a model-driven architecture. Yeah, and then there's this whole concept which the literature goes in very much. It's not about projects that are going along. It's about deciding what the core base data products are of the organization, having the governance around making sure that, you know, we're not repeating, this data coming from source, this team owns that source, what are they going to do with it, understanding who's in the priority backlog to get landing on the data mesh. And those are sort of the base data products. And then moving to the point where we have derived data products, which is refining some of that data, creating new insights, new value on those data products. We're also making sure we were doing analytical data products, which is within the same cloud-based infrastructure. How do I use these base data products to derive new insights, new value, machine learning use cases, etc., to drive value for the end customer? So we don't want to be in a sort of mode of saying it's data for data's sake, just if I build data, it will come. We also wanted to go end to end and say, we have data, but we're driving analytical insights and we're driving business results out of the back end of that. The final part of it is, you know, we want to use cloud-based infrastructure and cloud-based dynamic environments, but we don't want everything to be monolithic. If somebody tries to experiment and it doesn't really work, we want to make sure the security is there and the isolation is there, that they can experiment, try something on their own sort of effectively sandbox, and we can go from saying it's an alpha experiment in dev to a beta in UAT. Maybe it's going to production, but it's not marked as a final product that's shareable by anybody else. We won't grant anybody else access. Then when governance finishes and goes, okay, this is now a certified data product, now we can basically mark it as being available for general use, and then people can have workflows say, now I want to consume that GA product. So that limits the sort of blast radius of any sort of mistakes. So that's a bit about the why.
What we are trying to do is essentially data innovation at enterprise scale, right? So the other thing is always we've realized that typical warehouses as they were built, right, there were problems with the infrastructure scalability. Whereas what we were trying to improve on that with the cloud was infinite scale. Autonomy and self-service, as Simon mentioned, that's what we were trying to prove out. At an enterprise scale, that's a big deal, right? And also there was computational governance, right? So one of the things that we've always had is, right, governance is an afterthought. Whereas with the data mesh architecture, we were trying to sort of embed that into the architecture and the data pipelines and all of that as part of BAU, right? So we want to do that. Now, effectively, how can we do this, right? So where we started, right, the hypothesis was let's start small, right? Start with a 2-pizza team. run it as an innovation hackathon, right? Prove out the capabilities. We put a very acute focus on this for 2 weeks, right? So some of the very enthusiastic engineers got together and they proved this out over a couple of weeks. It was time boxed. They were free from their day-to-day jobs and they did this. Obviously, there was stuff that happens in parallel, but ultimately they were putting a lot of acute focus on this, right? The other thing we focused on was that let's not just try this for one thing, right? Put a few different use cases in the mix, right? And again, that's useful because not everything will succeed, but we'll have a few things in the mix. And we also limited the dependencies, right? Because as you know, when we're trying to do any of these activities, trying to prove something, if you've got a ton of external dependencies, things just don't happen, right? So what we did with this is we tried to play with the tech we had, right? And that's how we limited any external dependencies and we were able to deliver this. Now, end of the day, right? The data mesh architecture, right? Ultimately, it's an architectural paradigm, but it encourages product thinking in data, right? So data becomes a valued asset. Data becomes a product in itself and has a life cycle of its own. And it shifts focus away from projects because projects are effectively for short-term outcomes, which we are trying to deliver, whereas products have a life of their own. They evolve over a period of time. Right. We focus on strategic data sets, as Simon mentioned. And one very important thing that we want to achieve with the mesh, right, is that build data products that can be used more than once, right? So it is not single-use data products, it's multi-use data products. So that was the hypothesis. It was quite a challenging exercise. I mean, initially trying to get people to start thinking differently. The biggest challenge is the mindset shift, right? And to get that embedded into your teams and trying to start thinking this way, it's quite challenging initially. But once your teams start getting used to the idea, they'd never want to go back to the old days. And that's kind of how we progressed with it. Anything to add to that, Sam?
Yeah, so it was the focus on innovation at that time. What problems you want to solve and the different use cases that came up. So there was a machine learning use case that came up. One of the engineers who did that ended up getting an innovation prize for that. There was a couple of use cases I won't really talk about, but the fun one was, we picked at them, we went at them, we were using existing private cloud scalable infrastructure. It was a kind of like the art of the possible activity. And we picked one of those projects was slightly boring, slightly prosaic, whatever, not very interesting, but I kind of fancied that one myself because I could really see how that had a potential path to production. So amongst these hackathons, these proof of concepts, these ideas we experimented, we put out there, one of them was basically identified as, do you know what, that's something that's going to pay for the initial initiative to be picked on. And so the idea of understanding, what can we achieve, getting the art of possible, and then finding one and saying, let's get that one out there. And what often happens, all these data infrastructure type things, it's like, well, it's an 18-month program, right? And so we're just going to start bundling down the meetings, road and see when we possibly get to UAT sometime in the distant future after moving the goalpost 10 and 20 times. And of course, that runs completely counter to the idea of the data mesh, platform-driven, computational governance, the ability to deliver something fast, the ability to innovate with data. So we started straight from the beginning saying, well, how can we innovate fast, even though they don't necessarily have the guardrails and to prove the point. And so, yeah, if you really want something to be really sticky in 18 months' time, you really have about 3 months to make your case, get into UAT, 3 months to harden it, 6 months, roll it out, ramp it up, get the client approvals in place, get into the next year, get it hard and get it rolled out. And so, yeah, we're always aiming for do something as fast as we possibly can because there's going to be lots of other things that we have to do to get the engagement and get the clients signed up and get the end-to-end win. So very much an acute focus on trying to get things done up and running very fast. And the whole platform became all about these automation to make it as fast as possible to innovate with safety, with guidelines. Yeah. And one of the sort of things that we find very much is a big theme as well. I really like this idea of all this data product innovation, but I'm petrified. I'm petrified about governance. I'm petrified about chaos. I'm petrified about duplication of work. And, we tend to sort of have the sort of two sets of thoughts about that. We really want to innovate, we really want to have value, but we don't want to end up with the kind of problems we've historically had in these large organizations. Historically, what's happened is everybody takes a copy of the data, everybody starts a project from scratch, everybody's kind of getting it from somewhere that maybe they shouldn't know back to source of truth. And we end up with this giant spaghetti ball of FTP and various initiatives that are moving data around. And when people come back and go, they're really, really worried about the lineage. Where's this come from? How do I trust this data source? The key point about the data mesh is, while we can innovate fast, while we will allow people to get out there and prove something, the gate to being a certified data product has to go through the necessary controls to understand it is governed. But it's not do all the governance before we start. We get teams to sort of innovate and prove the point, and then they have to and experiment with the technology. And then the process goes, are you getting this from source? Is it the right source? Are you revending other people's data? Yes, no. So we have a dual track between the governance and maturity of getting it done and the actual start to construction and start to innovate. And of course, you can't get to production unless you pass all those toll gates. So on the one hand, we have the idea of innovation and agility and experimentation and quick to start something in the dev environments. On the other hand, we have, you can go through to production, but it's not a certified finished product because we've decided an end-to-end use case, and you can be sort of a beta product, not quite signed off for general release, but there's a proven use case, 2 different versions of the product that eventually gets to the point, okay, this product is now a certified base product that has all the data quality and governance associated with it. We're now going to use it as a sort of GA product across many, many use cases.
Absolutely. And also about the kind of environment we create with these things, right? It creates a safe environment to innovate. Because end of the day, what are teams and engineers generally worried about? It's about things breaking, right? Whereas with this sort of a hackathon approach and early innovation, we create a safe environment where they can experiment and try new things. I think it's a huge motivator actually, because it's not just about doing this early on in any initiative. It's about embedding this as part of your regular life cycle of development or any product life cycle, because teams ultimately want to learn new things. Engineers want to progress their careers, their experience, their knowledge, right? And giving them a safe environment is step one. To actually start doing that. And what you see from that is that actually the best ideas come out of that, because they start getting quite a free rein on what they can do. One thing we generally see also with these sort of things is that people who actually work on these kind of hackathons start focusing on solving day-to-day problems. So the net is positive from an organizational perspective as well, because ultimately they are getting something in return, and that kind of levels up. So I'd say encourage this through your teams, through your organizations, because this actually motivates people substantially. I mean, the feedback from the engineers who worked on this with us, absolutely phenomenal. I mean, they loved it. They wanted more of it, and we did more of it. We did quite a bit actually, and we keep doing it even till today. And yeah, it's just a very positive way to actually encourage your teams.
Yeah, and I'd say, it's about the approach. It's how do we have the approach of small teams? How can they do, automation? How can they have guardrails? How can we actually get them set up? How do we do IDM? And so, yeah, we started off with the available tech at the time. It happened to be on-prem to a very large financial service organization using sort of Hadoop-based technology at the time. But we didn't want to start with, well, we have to pick the right technology to make a start. What we're starting was we have these use cases and have this need to apply scalable cloud-based sort of architecture, as private cloud on-prem, which is probably not really cloud. And so we were basically discovering the ways of working, the patterns, the access controls, even though quite initially we were running into the problem that the technology we were using wasn't really designed for spinning up lots of concurrent innovations. So we get later into the story, but we were very quickly able to were fortunate enough to be sort of piloting on their big public cloud initiative with one of the big cloud providers at that time. And so we flipped over from trying to approach on-prem on private cloud with Hadoop technologies to moving over onto one of the public clouds. We talk about which public cloud?
No, not at the moment.
Not talking about which public cloud. Okay. That particular financial organization. But the point was, what was portable was the ideas, the concepts, the ways of working. And we'll talk a bit about the approach, but basically it was about 6 to 8 weeks to port onto one of the big cloud providers, because the approach we took which I'll go into a little bit later, was model driven, that we're defining the data products and generating the bindings to the actual infrastructure and generating the publications to the data governance. And so we really just had to change the drivers. So over time, we've done this for that particular bank. We did two different storages, one major cloud provider, on-prem, and another cloud provider. We've gone to another organization. We're using a different cloud-based cloud provider on a different public cloud. So it's not about this technology gets me a data mesh. It's a data mesh is a way of working and a way of organizing ourselves. How do I bind those approaches to that particular cloud technology? That's how we do.
Absolutely. So, I mean, what was it that we did, right? I think we've kind of touched upon a lot of these points already. But ultimately, how do you go about putting a data mesh in place, right? So there's quite a few high-level, broad sort of things that you need to look at. Starting from the top left, what we've tried to list out here is the sort of key common themes that we have seen. And this is not just about our first or the second. You see this across the piece. We've been speaking to a lot of industry leads in sort of similar spaces. And ultimately, there's a common theme that is appearing, and it has been for a while, and it's improving on as it goes through the industry, right? Is you start with, ultimately, beyond experimentation, at some point, the data mesh has to be productionized, right? So what is it that you need to do to put that in place, right? The first thing that we started with is cloud-based infrastructure. Now, it's important we talk about this because ultimately, whatever be on-prem infrastructure, just will not scale to enterprise scale, as which we were operating in a big financial services organization. So cloud-based infrastructure is key. Right. Now, once you get past that, great. Now we got a bunch of infrastructure. What do you do with that? Right. So when we ventured on this, we started looking at a model-driven approach to the architecture. So as opposed to sort of think, well, this is a finite set of things that you can build and we will do it for you, or a central team takes away all the data engineering work from you. We started putting a model-driven architecture in place, and Simon can go in a bit more depth about that. Ultimately, that encourages teams to get a sense of autonomy, right? Because although the model-driven architecture has a bunch of guardrails into it, but it still offers a lot of freedom and autonomy. And by doing that, you sort of take the toil away from the teams. Yeah.
So I just noticed some questions on the chat channel, so I thought we'd just maybe just pick up those as we go along before we dive into this. So we have a question from Rodrigo. Just calling out recording. Were the problems of the hackathon predefined by management, stroke product people, or were they defined by the engineers that were working on it? Tony said a mix of both. I said it was a bit of people submitted a bunch of ideas. Yeah. We had a panel of interesting people, and then we picked some of those ideas. So some of them were genuine engineers sourced, and some of them were the ideas that the product people who were sort of on the sponsor side was keen on. So at least it was directed towards things. So there was like fun engineering things that wouldn't it be really good if we could mine the API logs on the API gateway. And it's like, well, that would be fun, but it's not really adding business value. So that one didn't get done, for example. So there had to be a focus on some business impact, for example, rather than just, I want to use big data for some sort of technical analytics.
Absolutely. And you have to ask yourself, right, where do all the ideas come from? No single avenue can actually give you every idea that you need, right? We have to draw on all avenues and all lenses to this, right? So if you look at from a senior management product perspective, ultimately the sponsors have to get something out of it, right? Maybe not immediate term, but they are looking at a direction of travel, right? So they have to be engaged in the process. And one of the best ways to keep people engaged is to actually draw on their ideas and get them involved in the journey. On the flip side, engineers have a lot of cool ideas because they are starting to see day-to-day problems with the work they do. So everybody sort of feeds into it, right? It's heart and mind game, right? Ultimately, and we want people to be fully engaged. So it's not either or, right? It's a mix of ideas from all sorts of avenues that we had.
So another question on the chat from Bill. I don't think I heard that the driver was to quickly absorb a new company into a current product or a new product for the product line. Anyone with a very acquisition for growth corporation in that situation? Okay, so large financial service organizations do have a lot of inorganic growth, right? And so that leads to a case where, so the organization we work on have multiple thousands of people in IT. They have core accounting platforms, for example, that have 200 people on it. They have multiple instances. They have one that runs for jurisdiction in Europe, another one that runs for EU, US, Asia, whatever. So in these large organizations, you see all that stuff that's been running there for years. You get a big architectural diagram saying all this stuff is in demise. Like, when is it demising? 5 to 7 years. So you can't really take a shiny new only sort of strategy. You have to basically say the value for the business is around these data sets that are coming from these parts of the underlying business, and they have a mixture. They have the US platform and the EU platform and the Asia platform, and on different versions of the same software, different vendor softwares. And sometimes those teams are not necessarily, how you say, very aligned in the same ways of working. So that becomes a very big organization. So do we start with governing them as one across everything? Or do we start sort of trying to get each one of these platforms in and then combine them to be a combined data product later? So the answer is we've seen all of the above. We've seen the different evolutions of how do you overlap the actual data products and the enterprise products onto to understand what are the source systems should be feeding from in what order. And you get we've had some platforms that were very modern and doing event-driven Kafka and knew what their data product basic canonicals were going to look like and go straight Kafka straight into cloud. That's very good. But we also had, S400 mainframe type existing platforms that really struggled to get efficiently out of their system a nice clean data product. So there we sort of say within that base data product domain, it's private. They have private tables and private engineering they need to do to get the data in, to do the byte temporality, to get to a finished data product, and then they have a sort of public interface which is governed, which is what's going out the door. And the very modern ones can just go straight, they already have the data on Kafka ready to go, and it's kind of like almost straight in. Whereas some of the existing systems, they have to go and, extract it as efficiently as they can using the technology they have. And then they have to do some cloud-based compute to refine the data product, reconstruct their data product from the constituent parts, which they couldn't do the joins on the mainframe kind of thing. So the answer is, in these large financial services organizations, you have a bit of everything. And you don't want to just attack the new first or the old first. You want to take some representative samples of those to see that you can stretch both ways, to the very new, to all of the strong one. Yeah. And so if anything, we saw that the teams who had everything new were a little bit less keen to get the central platform teams help to do something new and innovative in cloud, because they want to do the new innovation themselves. The teams that had the more legacy stack, who are kind of struggling with that, are often the ones who really first get the benefit or see the light of, oh, wow, I'm getting this platform automated tool. There's some restrictions on how I work for standardization and governance, but it's really, taking us forwards in leaps and bounds. And when those teams succeed, then it kind of brings everybody around the more modern teams to say, do you know what? I need to be as well playing on the data product strategy. Well, I can do my own thing off to the side. Actually, we should do a dual project, maybe doing something off our side, but we also need to be part of that general data product strategy and the data mesh to build the assets that the organization really benefits from.
Absolutely. I mean, to draw on the example, I think Bill's mentioned on the chat, right? So you talk about company acquisitions and growth across corporations, and how do you go about it? Ultimately, the mesh is a fungible model, right? What we have seen is business growth falls along the same sort of lines as acquisitions, right? Ultimately, you grow by acquiring, or you grow by acquiring new companies, or you grow by acquiring new business from competitors. We've seen the latter quite prevalently in the industry, where obviously clients are moving across from one provider to another. The same sort of constraints and challenges apply to that, right? Actually, one of our early adopter use cases was about exactly that, which was a big client being moved across from one provider to another. And at that point, integrating all the old architecture and all the old data sets into the data mesh was one of the key things that we were trying to achieve. And that is actually what proved the full value of it very early on, because we saw that happen at a rapid pace. If you look at the model-driven architecture, what is it offering you? It actually offers a way to integrate heterogeneous data sources into your data architecture with a very, very small lead time, right? You can cycle through that fast. You can, as you discover the data more and more, you can start integrating that, right? So if anything, it proves the point. And I think as you go through the journey yourself, wherever you are and whichever part of the sort of maturity you are in this, you'll see that actually what is the mesh offering? Mesh is offering a fast-paced innovation alternative to data engineering, right? And data architecture. Over and above that, obviously, all the good stuff around data product lifecycle, governance, all of those things, icing on top, right? So yeah, that's that really. Simon, I would like you to, if you can, just talk through the model-driven architecture that we have put in place in all.
Yeah, if you want to skip forward to that.
I am on the slide, yeah.
No, I had a custom slide.
Okay, yeah, all right, cool.
I get the diagram. Use my latest version. There we go. Yeah. So very crude diagram, just to illustrate the point. So the approach we were taking, which was inspired by seeing other sort of investment banks' ways of doing risk calculation models. So I'd worked on two very famous investment banking large-scale risk models, platforms about core engineerings and hundreds of developers actually building parts of their risk models. It's to take an approach of saying, well, I have a single source of truth, which is in a source control server. Let's call it Git, or it could be Bitbucket or GitLab or whatever it is. And we want to say, based on a declarative explanation of what are the things I want to do. I want a data pipeline. I want a Kafka connector. I want tables. I want views over my tables, all these kind of things. So we were generating, typically we'd use Terraform, would generate a sort of grammar description of what data infrastructure should look like. So I want table, Kafka integration, I want landing stage, I want files, I want tables, etc., etc. And then for the tables, we sort of have a CSV file where we say, well, what is the SQL type? What is the SQL name? What will be the Kafka Avro field? If we expose it in GraphQL, what will be the GraphQL field name? So we go through this single source of truth. What is the description? What is the classification for governance? What is the sensitivity classification? So it's basically saying there's a single source of truth for what a data entity is and how that entity should be bound to physical or messaging or API or documented. So we take that and we run it through things like SQL templates as well to how we're going to actually basically say, if I tag this, I know that these are the business fields. I know this is the version field. We want to run by temporality. We get the information. We can generate the necessary SQL to run by temporal ingestion across any store, because I can have templates that run for this SQL engine, that SQL engine, BigQuery, Snowflake, Max Compute, Hive, Data Synapse. I've done all of them, right? And we can also basically have some configuration about how I want to make data product endpoints that I can query those underlying data products. And for that, we can generate the tables, the landing stages, the ingestion pipelines, the documentation for Kleber, and push them out the door. And so that sort of idea that we're describing the intent of the user and using sort of model-driven architecture to describe what these things are, and using infrastructure as code and Terraform to create all those resources was how it becomes so successful. So what we do is in a 2-week sprint, we will be engaging with the team that has the data source and say, okay, let's just land one thing from your core platform, right? Let's help you guide you through defining what your business entity is, what the fields are, what the keys are, but it's up to them. They just design what it is. We'd explain, well, okay, you can have this driver that either gets to CSV if you're doing mainframe, or we can do JSON and Avro for Kafka. So we've got different bindings to different sort of data sources. Pick the one that works for you. And then within a 2-week sprint where people are actually busy, they've got other things, they're busy, we'll get them set up in dev. We'll run our sort of tenant provisioning pipeline. We'll set them up with the Git repos, Kubernetes namespace, a group on Airflow as the coordinator, all the things. We sort of get them going and say, well, okay, here's the hello world example. Now you go and plug in the details. You go map your fields from your JSON, your CSV, or your fixed file, figure out how to push it up into the cloud. That's easy, that's a sort of problem. And we'll actually see you in 2 weeks do an end-to-end ingestion with bitemporality. At the end of that, as long in parallel, we're doing the governance, should they be on the data products roadmap? Should they go into UAT? What are the data entities you should be building in UAT? Assuming they get the green light, shortly after that, they're self-service. They can define, 10, 20, 30, 40 different data ingestion pipelines for their different data entities, start filling in their information to Kleber, and we manage everything. So we're managing things like What is the sensitivity? Is this PII, not PII? Okay, well, because we know it's PII, we know we have to mark it as PII and Calibra. We know the Calibra governance workflow has extra steps around PII. We know we need masking policies. So depending on the data store, we'd be using native masking policies. We know masking policies assigned to AD groups, et cetera, et cetera. So when the next team comes along and say, well, I've got highly sensitive or restricted or PII, we've already built the plumbing and the infrastructure. They can just slot that in, mark things as appropriate sensitivity level. We generate all their infrastructure for them and make sure that they have all those guide rails and governance in place. So that's a little sort of view about the sort of the approach we take. And so the answer is, are we slinging one particular product? The answer is no. We take this approach and we fit it into what is the enterprise change management system, data governance, API gateways, what cloud coordinators, what cloud database they are. So we take the approach, the ways of working, the automation, but we've implemented it in different sort of guise and make sure it works with both the IT change management system and the data products governance processes.
Absolutely. Bill's question, Simon, is what is the data format represented on the icon on the left? I think he's referring to that.
So data format, that's a GraphQL. So what we found is that we want to have APIs for the data, and so as an opt-in thing, we say, well, if I define that, hey, this is the physical field I want to land in the data mesh, you know, it's a varchar. These tend to be compressed columnar stores, so we don't sort by size. It's just varchar, compressed columnar, or it's a Boolean, or it's a date. Well, we kind of know then we have the mapping. Well, what's it come off Kafka? Okay, well, it's a date field come off Kafka, goes a date field into the cloud-based data warehouse. Okay, so what would you look on API? Well, it would be on GraphQL. It's a very typed API. I know it's a scalar type called date, or it's a Boolean, or it's a string, or it's a 64-bit float, etc. So what we found is, for a data products perspective, in Calibra, my data product has these 10 entities. What is this entity? It's position, it's transaction, it's asset, it's exchange rates, or whatever. How many fields do we have? Well, it's analytical reporting and it's financial service. So they're very wide tables, right? They have lots and lots of fields. But if they mark in the config, like I want to expose this as a data products API, they mark that, then we'll generate the GraphQL types and we can generate the mapping for the GraphQL engine to the database. And so that team automatically gets a GraphQL API for a type that exactly matches what's in Calibra. So you have the GraphQL documentation saying, well, it's a Boolean, it's a data, whatever. You have the Calibra documentation say the same thing. And now you have a read-only endpoint that's returning types, because it's a typed endpoint for GraphQL, that match what's in Calibra, that matches what's in your database. So rather than people handwriting REST endpoints or GraphQL, any sort of endpoints, we can generate for them. So the reason why this came about is we had one particular team started spinning up endpoints for their data product, and they were writing about 3,000 lines of Spring Boot code with security to get one thing going, and they were sort of like having to customize how things were grouped by. Kind of looked at that and went, well, actually these days you can do GraphQL Java engine on that, and you can basically do that configuration. It can do grouping and all kinds of nice presentation format out of the box. So we ended up writing. Initially, there was less than 1,000 lines of code just for a read-only endpoint that went to the data product. I kind of got to a couple of thousand lines of code with some look-ahead optimizations, etc. So we ended up with one generic endpoint teams could spin up that would basically serve an infinite number of data product types. And what they did was they could just define what the GraphQL query was, get transaction by date and type. They would just write a line, well, that's what's the query that I'm exposing as part of the API. Then they put in a SQL. This is the SQL I want to write against Snowflake or BigQuery or data science, whatever storage we're bound to. So they have to change the dialect a little bit to it. And therefore, they would automatically be able to push out that, hey, their types have expanded, there's more columns and fields, and there's these endpoints. And we're just generally mapping those GraphQL query endpoints straight through to SQL queries. So we end up with dozens of teams deploying their own generic GraphQL endpoints, and they're just configuring this GraphQL query parameters mapped to these SQL query parameters against the database. Yeah. So that was a really interesting thing that we've done against different data stores.
Yeah. Yeah, I mean, the next question, Rodrigo, again, excellent question. Why Calibra? ultimately, what is the mesh encouraging? The mesh is encouraging an ability to quickly integrate with what's in the enterprise already, right? The mesh is not looking to have a one size fits all for the whole of the enterprise. Where we've seen this, right? We've integrated with a few of these sort of data catalog, metadata management tooling, and governance tooling. So Colibra is one. There's another one we had also implement one of the other cloud providers. But it's effectively what's there already, right? Because most organizations are much further along their journey around the implementation of governance frameworks. And us coming along with the data mesh and saying, yeah, bin that, start again with a new thing doesn't make sense. So what we're trying to do is with the model-driven model, or architecture, sorry, we're trying to get all the metadata and piped into the governance frameworks as they exist, and unlock the potential. Because one thing is that the data mesh effectively, if it as and when it matures through the organization, it will have high amounts of data concentration, right? And having a few years worth of big projects running off the back of it to actually start doing this just does not work. So what we are trying to do is encourage as an approach, integrate into existing change management, existing incident and production metrics, existing infrastructure and cloud providers, and so on, right? So that's kind of the thought process behind it. And we've seen it quite successful because most of these things are about actually reducing and removing the barriers to entry, right? So to adopt an existing tool actually just expedites the journey.
So I'd say what's going to happen, we're starting to see a lot of products that are data mesh native, but the problem is that big financial service organizations already have a bunch of stuff that they're in flight or moving or migrating or demising. And so there'll be many years coexistence between old and new, many years to build the data products across everything and demise existing systems. So the regulatory pressure in financial services say, we want you to explain to us where all your data comes in and goes out. And it's not just about PII, it's about, are you in violation of your data licensing to Bloomberg and Reuters and whatever? Because the banks, for example, they get their own prices and their own market data. They end up accidentally putting out reports for the clients, but that's in violation of the licensing contract. They should use the client's API key, and the client should pay the bill at their cost and rate or whatever. So the regulators looked at this and it's a mess, you need to sort it out. So what we find is banks are basically able to sort out the whole problem, the exact problem as it goes along. Building a data mesh on data projects, that's solving the problem. It said, do you know what? We're not going to have this proliferation of stuff copying. We're going to figure out where are our golden sources. We're going to build these data products. It's going to be delegated golden source. That source system that's allowed to sort of be the single vendor for that is going to push into the new cloud environment. And from now on, anybody new, they should come up and basically pick it from that place. If they want to do analytics, we're talking the difference between operational data and analytics. If we want to do analytic, go to the right source. But at the same time, they have to be documenting everything that's going on before that gets demised. So we can't come along and say, well, the data mesh is now an island that doesn't exist with the rest of the data products and data governance strategy. But there's nothing to stop us dual writing. So at our current, and that's happening already, at our current place we're doing it, it's going into Colibra because that's doing data governance across everything. It has special workflows for data products because they're clean and they're new, and they're different workflows for mapping legacy data problems. But we're also publishing to something called Marketplace. And Marketplace is more about highlighting what's new and what's available and how you can innovate with this data. And it's not encouraging the other data sources, the legacy data, it's encouraging the new data sources that are in the data mesh. So it's not one size fits all. We can't do anything unless it's Colibra or it's Google Cloud Catalog or it's this or that or it's some open source. We say, well, where do you want to write this information to? And you might want to dual write to the enterprise thing that's dealing with everything with data mesh and put it somewhere that's data mesh specific. And that's it. It's not one size fits all. It's an approach and integrating with what's there. And that doesn't have to be one thing. It can be two things.
Yeah. So Subbu, I think you've got another question here, essentially building interfaces that map to target data stores / lake.
Well, that sounds like virtualization, right? So there's and one size might not fit all for many of these reasons, right? So if we wind up a little bit and we talk about the financial services domain we're working on, where we have these existing big accounting systems that are really taxed and stressed, right? and they've already had to copy the data out into a data warehouse to get the history, to do the analytics, the reporting, start to do ML, to sliding window time averages. But then they can't hit that because they're going to even destroy the data warehouse. They need a data mart copying it. That's the one they're going to hit. So in that, you can't take that innovation. They've had to put the 2 steps and say, do you know what? I'm going to virtualize the underlying operational data store, which is struggling already, right? You're just going to take down the whole system. So in that, I'm not saying you won't do data virtualization for data products. That's a good tool in the box. But in this sort of world, we're on-prem, we've got these big legacy data lakes and data warehouses. What we want to do is get them into a cloud-based columnar data stores for analytics. And then when you start to put the data product there, oh my God, you can do a lot more now because you have the cloud compute, the scalability, the metered billing, the billing on demand or whatever. So we're just saying, the first instance is copy to cloud to get all the benefits of the cloud, but that's not the only way you would do it. So in some particular jurisdictions, they don't want to use public cloud. And then you might say, well, that particular very security sovereign wealth jurisdiction, they're going to go with data virtualization. Okay, well, they just throw more hardware at the problem. We can do that. But it's one of the tools, one of the approaches. Across the places where we can copy to cloud, we will copy to cloud. Why is that? Because cloud gives us a lot of benefits.
Absolutely.
But it's not one size fits all.
Absolutely. And the other thing is, what is the mesh trying to achieve? We have to always keep asking ourselves, what are these different architectures trying to achieve? Mesh is trying to bring parity across maturity levels in an organization, right? So where we've seen in financial services, you've got core platforms, OLTPs built over the decades, right? Some still mainframes, AS400s and the like. And how do you actually make that work with just abstracting over it? You just can't, right? So there is an element of, we have to shift the load off of those core engines so that they can do what they do best, which is the core operational processing, and shift that load onto alternative data sources. Now, well, you think about it, that's typically what warehouses have done. What this is encouraging is not just a matter of copying the data across or a federated store, it is also encouraging governance and a data product life cycle. So it's sort of bringing a lot of these sort of good practices to data. And as a culmination of all of that, you get an architecture that can scale infinitely, right? Again, it is not a silver bullet. It has an evolution. Initially, you start seeing some early adopters come into the architecture and start getting some benefit out of it. And as you progress through that, you realize that the economies of scale kick in because you got some great data products being published. Initial versions maybe, and then they evolve. More and more consumption starts getting driven through that, right? So it's not just a matter of, well, here's an existing store, let's virtualize on top. Some approaches might work, but what do you do in case of your old architecture or core platform just cannot cope? Because modernizing those things is another 5-10 year program, right? So to start unlocking business value quicker, right, this approach sort of gives you the ability to do that, right?
Yeah, the question, sorry, drop some of the icons. So, just going to the icons around the side, we've got cloud data warehouses. Some of them have done is, Cloudera, BigQuery, Snowflake, Max Compute, and Synapse, right? And it's like pick it, right? And some of these large financial organizations are spanning multiple of them. There's next block down, that's Apache Airflow. It's just the job coordinator, but we're generating config that can go in Airflow and templates go in Airflow. Well, it could have gone in anything. Probably not, God help us, control M, but anyway, we can use any cloud-based coordinator or API coordinator. We happen to be using Airflow quite a lot because it's supported by a lot of the cloud providers, but there's nothing to say we would generate the config to run in something different. The sort of red icon is GraphQL. I touched on that we can generate we know the bindings of the tables to the source files or the source messages in Kafka. We can define the name of the attributes on the based on outbound API, and they can be different names. And so we can generate those, all those types and allow them to put like the query parameters and what the return types is, and we can auto-generate it. But the answer is it's not limited to that. Anything else we need to plug in, we can plug in because it's binding the entities, the model, the entities to generate the infrastructure. So I've missed off there is Kafka. So we can generate the Kafka config, the validation of the Kafka Avro schema for inbound to validate this message matches the right shape, and then there'll be Kafka connector config that will land in a table, etc., etc. So we can just keep on adding. Like so doing a Kafka connector to a cloud-based database involves a lot of moving parts. So our config just becomes, well, it's just a Kafka. I would like a Kafka. I want to use these columns. And we go, okay, to do a Kafka, I need this configuration, the other configuration to ingest Kafka. So we're building this abstraction so the engineer doesn't have to figure out, connector, what do I need to do? I need to do these 10 things. It's like, oh, actually, we just define one snippet Kafka, tell what the column entity columns are, give it a little bit of information. Off the back of that, we will go set up all the resources necessary to ingest Avro from Kafka into your cloud-based data store, and do by temporality, and take the descriptions and put them into Kaliber. And if it's marked as sensitive, we do the masking rules, etc., etc. So the answer, what's on the right-hand side, is whatever we need to plug into and add. So we can add more connectors, more integrations, more capabilities to go along, because we start with a product definition in isolation that we then drive out those particular bindings. We're binding the model to the actual infrastructure, as it were.
Brilliant. So Rodrigo, I see you've got another question here. It's fully loaded. It's got a few things in there. How about I take the second one? How did you convince the teams to invest the time? Probably a substantial effort time-wise to do this. Not at all, actually. It's not a substantial effort. I think the biggest challenge is not about effort. The biggest challenge is actually accepting that there is change in the way we think and we do things. And that's what takes time, which is why we never remember, you don't do the data mesh to people, right? The teams come and adopt the data mesh for what they're trying to do. So one of the things that we always work with is that work with the early adopters, right? The enthusiasts who are actually looking to do stuff in a slightly different way. All organizations that we've come across has pockets of this, and you sort of harness that, right? You engage with those individuals, those teams, and get them along the journey. The idea with substantial effort, I don't actually believe it is substantial effort. We haven't seen it at all, because as a collective, what does so you have to clearly understand what is the role of the data mesh, right? So the data mesh is about federating the responsibility and the governance to the individuals, right? So when a team is publishing a data product, they have end-to-end ownership of that data product. So
and so a key point about that is, say, bring your own data extraction.
Yeah.
So within these large financial service organizations, they have every ETL tool under existence, and they have Windows and not Windows and cloud and control M and all this kind of stuff. And what we don't say is, oh, we can solve data extraction for your platform, because it's already a solved problem. You can license and buy decent ETL products. Pick them, and how you schedule it, how you do it. Well, it's different team to different things. So what we say is, the contract is, you define what your data product is, we'll generate all the data product infrastructure. But now it's down to, right, well, how do you want to get data in? Okay, well, you can do Kafka, you can do streaming from Kafka stage, you can do this and the other, you can do file push. Okay, you're a mainframe, you're gonna do file push, you probably start with control M, happy days. So what we say is, well, based on what you've said your tables is, we can auto generate parsing and transferring. We can change those templates for your custom mainframe types. Now it's down to you. How do you want to schedule a task in production with monitoring that gets data out your core platform and pushes to us? You already have a data management team. You already have monitoring. You already have a production support team. We're not going to ask you to buy and license some expensive tool, integrate, roll it out. You go, if you want to, we can recommend one. There's already a team using a particular very good ETL tool, but we're not forcing that upon you.
Yeah.
So you guys will help you do the key rotation on cloud, the security, the integration. We've got examples of the team do that. We'll do the concierge usher that. But effectively, that team who can able to extract the data, they're going to get the data out their way, their production monitoring tool. And all they have to do now is push it up to a cloud via one of several standard mechanisms. So literally in a 2-week sprint, we get the tech lead to build the first everything and push through. They go, well, I can do it from my tooling and my dev desktop. Now I just need to deploy into my dev environments. I need these cloud SDKs to be able to push to this cloud bucket or whatever they need to do. But they know they can do it. They run the tooling themselves on laptop. They know it's compatible. So in that 2 weeks, they kind of go, yeah, I can do this. Getting the software patched onto their ETL servers can maybe take a little bit while longer, but that's life at a big organization. So we don't want to push. We've sold data extraction and ETL for an entire financial services. That's a different project. What we say is we've sold, when you've got that file, how to quickly push it into cloud-based data warehouse, do the by temporality, historization, data governance, all this kind of PII, right to be forgotten, crypto shredding, all these kind of things that we build on top of this. And so what happens is when teams realize they're not being forced to change their ways of working, they're just being given a ton of automation, then they buy into the whole thing, that they say, well, you know what? So we found a lot of teams as well, they got an account, Snowflake or whatever, and they were having lots of fun, but the work to get it over the line into UAT and prod was just a huge amount of work to deal with. You know, the design authorities, this and the other. So everybody had an experiment running, nobody had it working to production. And so the platform once goes through all that, good practice, the rotating the keys, agreeing with, the design authority and sorting it out and going whatever. So the team that comes along says, well, actually, I just plug a file in here and I get all that stuff done for me. I don't have to negotiate it. Now, if they want to vary from it, they want to do something different, sure, but that's a deviation from the platform, and you're going to have to go to the design authority and figure out what you're doing, right? And so that's sort of when we want to extend the platform to meet their needs, but at the same time, if they work within what's already there, they get so much, eventually see this is a massive benefit to get them going, right? And so to just the side of it, the second one I built, we had 230 data engineers had committed code to the Git repos, right? We had like over 30 different projects on a cloud provider. We had, a very large amount of what was going on the data mesh. So it was successful because it added value. We weren't forcing to do something that you didn't want to use. We were trying to partner with you to build something that makes your life easier, that you just want to use it. And once a lot of the strategic data products are on there, it's like, well, you can still write to your existing stuff, but you also need to put your strategic data products into the strategic data mesh, because that's the benefit. So yeah, it's getting the early adopters, getting credibility, maturing things, gets them into a use case, and then a critical mass becomes like, well, everybody wants in on the act because they can see the benefits of being part of the initiative.
Yeah, exactly. So I'm just going to quickly sort of scan through. There's quite a few questions in there. So is the downstream integration of the data product platform independent or specific to the targeted system?
Is the downstream no, that would be so. I'd say organizations have big financial services organizations have a strategy about how they want to deliver the data to their external clients, and we call that an omni-channel strategy. So they have a cloud strategy, a cloud database strategy, an API strategy, a data marketplace strategy, self-serve reporting strategy, and all these kind of things. So in general, the business sponsors on the business side want some consistency, but multiple channels. And then they're picking, well, am I using, a lot of them, big financial services want 2 different cloud storage engines or 2 different clouds or whatever. Yeah. And they're picking those for, they have to call design authority. We want to use engine A versus engine B because we need these features or those features. Yeah. And so no, that the product idea, the consumption side should be consistent and based on standards. On the publication side, well, it's completely data capture side. Well, it's completely bespoke to every different environment, whether they want to use flat file or Kafka or whatever they want to do. But we try and make sure that when it goes through the pipeline to be data product, there's coherency and consistency on that side.
Absolutely. I mean, the omnichannel experience is interesting, right? Because where we are seeing the evolution at the moment with all of this, right, is that it's great, right? How do you get data out? Right, it's great to put this all in, right? But once you've defined the data products, great, well done. Now what do we do with it, right? What we are starting to see a lot, right, is what is coming out of that is we need standard APIs, right? So as Simon explained, we get GraphQL going at the moment, which is basically pure config. Once you publish a data product into the mesh, you also get an API for free. So that's your one channel, right? Teams can actually access the data using that channel. That can help with all internal, external integration, computer-to-computer communication going. The next thing is, right, what if I want a more custom experience, right? Where us as eSynergy, we are investing heavily at the moment with our clients, is starting to build out an experience layer, which is omni-channel, so that the same data source feeds across multiple channels, right? And by doing that, you actually ensure that some clients might want to see the data, or some internal users might want to see data on UIs or portals or apps. Some might want to use APIs to feed into other systems, or some might just want to get to the raw data or reporting tools, right?
Or external marketplaces.
External marketplaces.
One or more external data marketplaces, we can integrate into those. We obviously have integrated one of them.
Or other third-party providers, right, who might want to actually host the apps for the client. So ultimately, all of these different channels start surfacing. The key being that once you publish a data product, there's a further question about this system seems very scalable. It actually is. Right? It is very, very scalable. And the reason for that is, as Simon said, you've got hundreds of engineers working on a single data mesh in one of the financial services organizations we worked with. How did that actually happen? And that's by allowing innovation at a smaller scale initially and encouraging that and sort of feeding that through the pipeline so that we can actually start seeing some output. One of the famous quotes from one of the CIOs I've worked with over the years was unlock business value quickly, right? And that's ultimately encouraging that, start doing this at a pace that the business starts seeing benefit of it. Your sponsors have to see it, right? Otherwise, why would they actually want to invest in this? It is quite a new approach of doing things, right? Agile isn't new. Ways of working has been talked about for a while. Microservices is not new. So why do this, right? And I think this is about building that momentum, right? And building on top of it, right?
So Rodrigo had a second question that Sunny went for the first part. Sorry, falling behind a bit. We're trying to skip forward a little bit.
Yeah.
Did you specify the old existing tables, the new approach, important for complete lineage, right? Okay, in the bad old world, everybody's copying data around and we didn't trust it. And so we just said, here's something I've just pulled from nowhere, use it. And he goes, no, hang on a minute. We need to go back and find how many hops it went through and who summarized it and what lossy thing it was and which exchange rate they did at which point, whatever. So that was that. Trying to track that is fixing the old worlds and explaining the old broke world to convince your regulator you're not doing something you shouldn't be doing. You don't do that in a data mesh. In data mesh, you have data governance say, I will identify who is the team that should be vendoring this. And I don't want summarized data through the old pipeline because we have a cloud-based data warehouse. I want you to go back and give the entity level data that you're stripping out of the operational store in the cloud-based data warehouse so it can do the summation, but it can also drill down to all the individual details. And then if you got on a mainframe, like 500 fields, which is labeled A1, A2, XC, X4. I've seen that really exists, right? And they're having to map that out to the data product. And in the mainframe, they have 14 different models. And so if it's model 14, you're using these fields, it's model 6, you use those fields, whatever. Does the customer, what do they see? I have transaction. What is this? Settlement date. Do they need to go, I don't trust you. I want to see the lineage on the mainframe to see which of the models it came from, where it is. Like, no, it is what we say it is, because data governance has said this is settlement date, and it's been signed off by the data steward, the data custodian, and all this kind of stuff. And IT was asked to do it, and it's a spec, and they built it and wrote tests. So in that model, when you get a vendor to do that mapping, you want them to document the lineage because it's helpful for you to understand how the data product matches to the mainframe, because you're going to swap the mainframe in a few years' time. But it doesn't make the product more valid. The product is valid because you did the work of identifying it and governing it and saying that is settlement date. In fact, the fact you're now calling it settlement justifies and basically explains what the thing is in the mainframe, right? So if you're applying governance to something that's broken in the old world, you need lineage to find anything to sign what you're doing, but you just the horse has escaped. If you're building a data product, you follow the data governance to find that this is the official value, the official team, the official explanation. Lineage is then just documentation for that team, so they can swap out their old mainframe down the line to something newer, and they have the documentation of how they mapped it, the strategic data product into existing systems.
I see, Subbu, I didn't quite finish off on your question. The system seems very scalable as we explained it is. What is the model here? So I'll share a little bit of experience on how we actually go about this, right? So whenever we are trying to get new people into the fold and trying to usher along the data mesh, right? Whether we are hiring into our teams or we are actually looking to get people going on this, one thing we actually ask is a pet question of mine, right? Is if you've read the theory of the data mesh, tell me how you would build it from scratch. If you had all the choices you could make yourself. Right. And the model really here is, right, it's about building the autonomy and scale throughout the architecture. Right. And this is why every choice that we make, right, has to be driven through those basic principles through and through. Why we think it is extremely scalable is because of each of those choices, whether it is data orchestration, whether it is data storage, whether it is pipelines, whether it's config, whether it's infrastructure, whether it's governance, right? Each of those pieces have been addressed and choices have been made throughout the life cycle of this, making sure that the things that we have are scalable in terms of volume, they're scalable in terms of diversity of data, but also they ensure that autonomy remains. Right? So we never centralize all this activity. It is scalable because it has federated ownership and federated governance through the process. And that's how you gain scale, because the scale exists in the organization. We take the scale away by centralizing this. Whereas what we ensure is that besides the core infrastructure and the pipelines and the sort of platform itself, all the SME activity and the ownership is federated. Right. So that's how the scale gets induced into the architecture.
Yes, but that's the question. Is there a term you're propagating for all this activity task? You're enabling with the data mesh, like data management architect. So I don't think we're making a new term. What we're trying to do, so even the language, what is a core data product? What is a derived data product? What's a private analytical data product? Each organization needs to go on its journey of understanding. So it's not about coming in and forcing new terminology or forcing new groups. It's trying to find the organization's terminology. But I would sort of talk a little bit about, how we organize it. We're building a config-driven data analytics PaaS, platform as a service, right? And so we provide a platform team that does the Terraform automation, the publish to Calibra, the generated APIs, all these kind of things. And there's a huge amount of IDM, provisioning, interfacing with whatever IT change management system is, all this kind of stuff. So it's a huge amount of platform automation. And then we don't build the data product. Why is that? We need tenants. Tenant teams have access to the underlying systems to use the product. And so, there is a product owner for the data mesh platform, right? And they're thinking about what attributes this platform need to do. It needs to integrate with Calibra. It needs these workflows to sign things off. There's a backlog of features to do. We want to do a Kafka integration, or we want to do another storage engine, so that the platform product owner is prioritizing doing that. We obviously have data architecture, we have enterprise architect teams, all making sure, are we doing the correct IDM, the correct targets architecture for cloud, are we using the right tools, are we taking the right approaches, etc. So there's a whole ecology and ecosystem about what we're building, where we're not prescribing that, we're building a platform that services that world. And so we can help out with a sort of target operating model a little bit. Do you want to talk about that?
Yeah, I mean, in terms of target operating model, if you think about what is it that needs to be done, right? So I'm quite wary of using names or trying to sort of reinvent job roles in the organization, right? So we always peel it back, right, to what are the different jobs that need to be done. right? And if you peel it down to that, actually, there's an ownership aspect required. So you need a data owner, right? Who actually owns the data? Who's accountable if this data isn't correct? Or who should be the one who says you can have access to this data, right? So there's that key role. There is a role which is some sort of stewarding capabilities are required in terms of getting the metadata tightened up, getting all the metadata lined up so that it is easy to understand, and getting all the governance in place in terms of approvals, if there is new data sets to be added, if there is downstream impact and changes to any of the existing data products. And then there is the technology counterparts, right? So some sort of technology team or individuals who are involved in actually putting all this plumbing together, right? So that's sort of people who do the SME activity, right? Now the SME activity is essentially who is actually building the data products. Then comes the sort of role of a central team. Now, I do believe that if you are trying to sort of implement a data mesh in an enterprise, there has to be, however lean, a presence of a central data mesh team that sort of continuously builds out the infrastructure and improves on it, and new features are added. This is not a very heavy sort of presence, right? This is ultimately owns up to the infrastructure, does the standardization and tooling available for teams to build it out. Now, how do these things work, right, in tandem with each other? The important part about any ways of working or op model is how do you prioritize which team gets this stuff going and whatnot, right? Because there's finite capacity in whichever organization you're working in. And I think it's all driven through value, right? We need to have a proxy measure or an exact measure of what is the value of this data product that you're delivering. Is it about monetizing it? Is it about improving the operating model, the operations process? It's about actually streamlining any of the activities, errors and emissions, or regulatory requirements or reporting, right? So all of these factors collectively come into what is the value that will be delivered through the data product. Now, you don't need to know what's a 10-year horizon for this, right? You just need to know today and tomorrow, what is it that you can do with it? And this is why we say, right, it's not a lot of effort to get it going. Once you get that prioritized, you've sort of got the operating model in place to encourage this. Now, that's okay for day one. What happens as you go along, right? Because there is a data product lifecycle that happens as you go along this process, which is new demand comes in, new attributes appear, new data models will appear. These have to be brought back into the fold, right? So all of these sort of the technology counterpart, the stewarding capability, and the data owners, they sort of come together and sort of manage this. And it's actually a very good, healthy model, right? Where we start seeing that value gets delivered quite quickly.
So Xiang had a question. How do you estimate in terms, do you have an estimation in terms of data delivery to the business teams, lead time or acceleration before or after with data product? Well, what we just described there is there's a process of prioritizing who's going to go through the onboarding process. So they said, well, we can help them. It's a business decision they want to make. This ticks the box on reg reporting, client wins, errors and omissions, blah, blah, blah. So that helps them classify who goes next. And then we say, well, in one sprint, we can take you through, we'll run the Genesis pipeline that sets up your infrastructure. There's some IDM you need to do. In dev, we're a bit lax about that. UAT, very strict about that. And then we get the tech lead to do something to go through. And in about 2 weeks, they get to see something going to and go, I believe I can do it. Now, their time to go to production is however long it's going to take for them to do the data extract engineering and get their servers patched with the cloud SDKs that allow them to publish to the cloud or whatever. But the point is, they're in the pipeline. 2 weeks later, another one's in the pipeline. 2 weeks later, another one's in the pipeline. 2 weeks later, another one's in the pipeline, right? And they proceed at their own speed. But this idea is parallelity. They're self-service doing their own thing. We spin up the infrastructure. Now they mobilize themselves. So eventually you're starting all these teams 2 weeks apart that are in the race. It's 3-6 months later where they all start crossing the line. Some of them will fall foul of, they had to do a platform burning change. They had to do this, they had to do that, the other. And it's just hard for whatever reason it was. They got distracted and whatever. But that's just life, right? But if I took back the beginning, I said, we used to just build the one thing we had to do, right? And try and force that one over the line in 18 months. Here, spinning up your cloud container, your namespace, and doing pay as you go, it's no risk. It's no risk to them to do it. So we just get them going. And then it's down to their prioritization of how long it's going to take them to get their, their pipelines up and running, the data products UAT'd and signed off. The first one we built, in this particular client, built the entire automation infrastructure, built the first data capture, and got into prod in about 12 weeks. To be honest, it was the first time they particularly got into a particular cloud provider. Then we switched it on, and then we had to switch it off because we realized that we needed to go loop back through the governance process and get the client permission to go to cloud. So effectively, yeah, it's as fast as we can get it done. It's as fast as the process around it get it done. But what you want is many different horses in the race.
Absolutely. Yeah.
In parallel, that's the organization scale. And when you see those wins coming through, that then brings belief. And then maybe if they're not doing it this financial year because they're distracted by a burning platform change, next year they have the skin in the game to sort of go. So it's a rolling,
it is
a rolling tide.
But Shung, I think an important point to all this is, right, that how do you get to an estimate, right? And there is no magic answer to this. I think the most important thing is you have to look at it in context of your organization. Right. As you do the early experimentation and adoption of the mesh, you will kind of get a sense of how this is operating at the speed at which, because there are so many factors in play, right? You might have different cloud providers, you might have sort of different automation, you might have different governance levels, you might have different change control in your organization. So all of these things play a role, right? Which is why I think, to be perfectly honest, there is no right or wrong answer there, right? You have to actually do this and learn. The most important thing is that be ready to fail early on and build on top of it, because failing fast and learning from that and improving is literally the sort of secret sauce to this. We've seen it work, and absolutely we encourage in the community to absolutely keep up the good work. One thing I also wanted to mention about this, right, is that obviously we are doing this sort of hour-and-a-half meetup and talk you through all of these things, right? But if you do want to talk to us, right, the details are on the screen, or just reach out to us at eSynergy. We'd be happy to help, right? So I mean, I think this, in the interest of time,
Yep, not particularly. Not any particular new. So people discussing any questions. Yeah, I think we're pretty done. Yeah, people asking for pictures of diagrams of the architecture to show. Well, quite a lot of that's proprietary to the financial service organization where we've done this 3 times. Yeah. And also the answer is, well, if we come to an organization, it's like, well, how do you want to organize your product domains? Which cloud provider you want to do? Which cloud-based technology? Yeah. So we bring the approach, the ways of working, the practices. We don't bring this thing because we're trying to adapt our way of working, of doing innovation with analytical data at scale to an organization. So, we kind of bring the expertise and the approach. Like I said, we can, with the right technologies in place, in 3 months, we can build the initial data mesh, right? As long as we have all the preconditions there, and then start to add more and more features to it, more and more integrations, more and more connections, and more stuff to it.
Absolutely. I mean, Subbu, I see you've kind of put a good spin on this, right? Your interpretation of the mesh, right? Again, right? We each walk away from the mesh with a slightly different interpretation. It's really not there is no single right answer here. The key is, how is it in context of your organization, right? So a collection of tools and systems which are standardized and purpose-driven, absolutely. But what you also need to make sure that we understand as part of this is, right, it's the endpoint or the delivery of this, the outcome is not a data mesh. The outcome is data products, right? As you go along the journey, as we are seeing with all the organizations we are working with, is over a period of time, there's less and less talk about the mesh, and there's more and more talk about the data products, because that's what delivers value, right? Mesh is a background thing. Once put in place, it kind of has a life of its own, and it bubbles away in the background, evolving organically. What you see is an explosion of data products, right? And I think we should all keep a keen eye on that, because that's where the true value is. Otherwise, why are we even doing this, right? So it's the products that have the value attached to it. Focus on that, keep that in mind, and you progress through this, right? Okay. Brilliant. Well, I suppose we are nearly on time. We've tried our best to answer all the questions we can. But by all means, just as a sort of closing remark from us, right? We are part of the community and we are more than happy to help and discuss and sort of understand your challenges. So yeah, I mean, we've got details on the screen and in the chat on how you can reach us. So please reach out and we'll be happy to help, right? So yeah, on that note, let's call it a day. And thank you very much and enjoy the rest of your day wherever you are and keep up the good work. Thank you.
Thanks, everybody.
Cheers all.
Thank you very much.